Welcome back. We are joined by Theodore Postol, a professor of science and technology and national security at MIT, who is a specialist on nuclear weapons, delivery systems, missiles, and missile defense. Was also done some work for the Pentagon. So thank you very much for coming back on.
Well, my great pleasure for being invited by you.
Well, I have been looking forward to speak with you because in this war against Iran, it's it's a largely a war about missiles and missile defense. Essentially, who can create the most pain and absorb the most pain is able to exhaust the adversary. And I thought you are, the recipient of this Norbert Wiener Award from Computer Professionals for Social Responsibility for
Yes.
uncovering all these deceptions which has previously been made about missile defense. So I thought, who better to have a critical view, cut through all this fog of war, because there is a lot of focus these days on narrative control, so it obscures reality. And I wanted to get your, I guess a good place to start is your overall assessments of this war. I mean, what is that stands out, or what is your takeaway?
Well, I think you got a fantastic assessment just recently from Larry Wilkerson, but I'll give you my assessment from my much narrower, because Larry I think is really broad and has all this experience, but from my much narrower technologist point of view. So let me caveat my initial discussion by pointing out that I literally have been working night and day to try to keep up with what's going on, and it takes time to put together slides and videos, which I hope I'll be able to show some that will be helpful. That will try to inform your audience, because looking at a video is one thing, knowing what it's telling you is another. So let me start out by just saying that from a purely technical point of view, again, not from this much broader and wiser perspective of someone like Larry has on this, it's very clear that this war is going as someone like I, and more importantly, Larry, would have guessed. I mean, it's what we're seeing now is in the initial phases of the war, the United States and Israel are doing tremendous damage to Iran. But of course, Iran is a country of 90 million people, and it's a very cohesive country with all of the internal problems it has. It's still basically a cohesive culture, and it doesn't appear to me that the situation is in any way favoring the outcome that both President Trump and Premier Netanyahu are talking about. That is to say, it hardly seems likely that there will be any collapse of the kind that both these leaders are aiming at. I have to say, though, I'm beginning to become extremely concerned with Netanyahu, who I'm going to say it just because I've been thinking about it. This man is a homicidal maniac, and this is the kind of homicidal maniac that could use a nuclear weapon at some point. So I think I'm perhaps next time I'm on, I can remind your audience about the capabilities of Iran as a nuclear weapon state. It is not a non-nuclear weapon state. It is not a nuclear weapon state who has built a nuclear weapon, at least as far as we know, but it is a weapon state that could build a nuclear weapon on very short notice. And it would not be possible to stop them from building a nuclear weapon, even if you were using nuclear weapons on Iran while they were constructing their nuclear weapon or nuclear weapons. They have enough enriched uranium hexafluoride to construct 10 atomic bombs, which would be much more than enough to finish off Israel as a state. Israel is not a state of 90 million people, it's 8 or 9 million. It's got a few large critical cities, and 10 nuclear weapons would be far more than is needed to end Israel as a state. And there is no way to stop Iran. I could talk a little bit about that at some future time. I have talked. Basically, what you need to do could be easily housed in a tunnel that's not necessarily especially large, and you could actually enrich, do the final enrichment you need to get weapons-grade uranium, and build a nuclear weapon that does not need to be tested. It's important to understand this is a uranium weapon, and it would not need to be tested. And it would not, it simply is well within the reach of Iran to build these nuclear weapons. So we need to start worrying, or need to start thinking about the possibility we could see nuclear weapons used. Now, I do not think Iran will use nuclear weapons against Israel first. But I think as this war goes on, Israel's situation is going to continue to deteriorate. And we already can see, I'll show some evidence for this, that the attacks on Tel Aviv and Haifa have been extremely effective. And it looks like the precision of delivery that the ballistic missiles now being used by Iran is higher than what we saw earlier. I think that is probably because Iran was using older ballistic missiles in the earlier attacks, since it's clear that their strategy has been aimed at saving their most capable damaging attacks for a long war if it occurs. So I don't think they were expending their most capable missiles during the earlier wars we saw in June, for example. So we're now seeing much more capable missiles. I'll talk a little bit about them. And also, we're seeing the effects of drones at a level that is really, I have to say, I should have expected, but I have to say I've been a little surprised by it. And this is because of two technical factors that are extremely important and is not nearly as well understood by the general public as it should be. In general public, I include the press. The first is that China and Russia are giving real-time, high resolution satellite data of the targets that Iran is interested in attacking in the Persian Gulf, in the Persian Gulf states, and also in Israel itself. So the location of these potential targets is known essentially in real time. Now, the drones have a homing capability that I'd like to describe, because I don't think people appreciate how extraordinarily effective this homing capability is. And basically, what I'll describe is how these drones, from thousands of kilometers range, can get real-time homing information and real-time guidance from Iranians who are sitting in control centers in Iran. So if you want to run a drone into a radar station or into a docked ship or into an oil facility, if you decide you're going to attack those, you can attack with essentially tens of meters precision, which is more than enough precision to essentially destroy most things that you're concerned about. And this is extremely important that people understand that these drones are extraordinarily problematic. They can be intercepted, as I'll discuss, but there are large numbers of them. They carry large enough warheads that they can do tremendous damage against significant targets, and they're ubiquitous. They're just ubiquitous. They're just thousands of them, and there can be thousands more, and they're just going to simply overwhelm what is left of the air defenses and missile defenses that are now being depleted by the Iranian attacks. This is the Ukraine War 02 here. What the Russians did in Ukraine is they used drones very effectively to essentially deplete the entire air defenses of Ukraine. And then Ukraine is essentially naked, and they could then go about their business destroying large parts of Ukrainian facilities. Now, in the case of Iran, they do not have a functioning air force to deliver munitions against Gulf War and Israeli targets. So they're confined to using ballistic missiles, but they have thousands of these ballistic missiles, and these ballistic missiles are more and more capable. And I'll describe some of these more advanced capabilities very shortly. Let me just so let me start by describing how these drones get their targeting information. And we see a lot of evidence that they have been destroying key radars in the Gulf states. The Bahrain naval base has been up in flames, and they've done tremendous damage. Unfortunately, I've been so overwhelmed, I haven't had a chance to put together the materials on that, but probably many of your audience have already seen it if they look at videos that are just on the web. But in any case, let me just turn on the share here. Well, what this slide shows you is a satellite constellation known as Iridium. Most people have heard about Starlink, but Iridium is something that's been operating a longer time. It operates at higher altitudes, and it's basically gives you satellite telephone operation. So it's like similar to Starlink. It what you're seeing, if you focus on the circles you see, what the circles show is the range at which an Iridium phone system on the surface of the Earth can communicate with a satellite. You can see the circle when I point it out?
Yes.
Or not? Good. Okay. And in the middle, we see there's a satellite. And so this satellite is sort of like a phone modem. It has about a 300 kilobit per second downlink, and a 700 kilobit per second uplink. Now, those numbers are relevant, as I'll show you shortly. If you see these brighter lines here, these are links between the satellites. So if I'm at a location, let's say under this particular satellite, and I want to communicate with some location that's on the other side of the planet. So so this next slide here just shows you on a Mercator projection, shows you the overlapping circles. So you can see that these, I think there's 76 of these satellites. I may have that wrong, but they're somewhere around that. And these satellites are in polar orbits, and anywhere on the Earth you can communicate with anywhere else on the Earth with a data rate of about 350 kilobits per second, or 700 uplink, 350 downlink. So if you look at one of these terminals, this is not a terminal, this is a device that goes into, let's say, an airplane or a drone. This is an Iridium mobile system communication device. It's small, it's light, it only takes a little bit of power, and it has an ability to communicate from the drone. So I'm underscore from the drone at up to 350 kilobits per second. Well, I've shown you, these are two satellite photos of Tel Aviv from about 1,300 feet above the city. And this top photograph just shows you a high definition photograph of Tel Aviv. This is the same photograph down here, but at 240p resolution, much lower resolution. This will give you 20 to 30 frames per second. So you're not seeing 60 frames per second at the resolution you can see. You can see it's slightly blurrier, but this resolution is more than adequate to provide the operator of the drone in Iran the information they need to then command the drone to do maneuvers. So you now have this global, I don't know what you call it, first person vision drones anywhere in the world. So that is very significant. So when you look at these drones, I'll talk about this shortly. So here you have a drone. This drone can have can be launched in very large numbers. If you look at this particular drawing of a launcher that carries 5 drones, if you look here, you can see this tube that's at the bottom of this drone, and what the tube is, this is a rocket motor. So what happens is when this thing is erected, when this cage that carries the drones is erected in a near vertical direction, then each of the drones can be launched using its rocket motor to get it up to speed, because it has a fairly underpowered propeller motor, but the propeller motor is only adequate to keep the drone at an adequate speed to keep it in the air. So you need the rocket motor to launch the drone onto an aerodynamically stable trajectory. That's, of course, easy to do. So if you look at a drone, you can see there are all kinds of equipment that you can put on this drone, and it's not hard to. In fact, we now know that the Iranians are using Iridium communications. So this particular drone doesn't necessarily have Iridium communications, but it's not hard to obtain that. Here is an example of a drone some very helpful individual who also works at the Department of Defense alerted me to an error I made in an earlier presentation. This is actually, it is not an Iranian Gen 2 drone, it's an American drone. But it looks exactly, it's indistinguishable from the Iranian drone. And you can see here you have an optical system of some kind. It could be an infrared optical system. It could be visual, or it could be both. This is one of the things that is extremely important to understand when you understand the nature of technology disparities that would normally be a problem, or in the past would have been a problem for less developed states relative to the more advanced developed states, like, for example, the United States. The availability of very high technology commercial systems, cameras that literally would fit between my fingers, infrared cameras, those cameras, infrared and visible, are extraordinarily high technology devices. They're extremely difficult to build and really require very high technology industrial bases. But they are commercially available ubiquitously. You can go out in the street almost and buy one, go into a hobby store. And so these things are available. So it doesn't matter that you can't manufacture them. What matters is you can obtain them. So, for example, when you have improvised explosive devices, which have done been a tremendous problem for the Americans in Iraq, for example, in Iraq, I'm sorry. Those devices are really incredibly advanced technology because they're an explosive device, which is well within the local technology capabilities, plus a very advanced cell phone, which is very, very far beyond the technology capabilities of the people who are using it, but available. Go in a store and buy one. So I take this phone and I attach it to a detonator on this relatively deadly but constructible improvised explosive device. And now I have a remote device that I can detonate from long range. So it's this kind of promulgation of all these kinds of technologies. A satellite system like Iridium that is very advanced, but is available to anybody. Who's going to say who's phoning? I can't screen phone calls on Iridium. I mean, it's not going to be possible. So an Iridium is designed to service aircraft. You go on an international flight, you want to look at videos, you may be looking at Iridium or more likely Starlink, but there are these fast terminals that are available, and it's just a matter of buying the device and installing it. So if we look a little further, so here is an Iridium, a hole for an Iridium antenna. You can see how large it is by the size of the hand of this man. And he's installing it on an airplane. So this airplane can have a cell phone. So you can have cell phone communication. If you, this is aerodynamically, irrelevant. I mean, you put this antenna on a drone, you buy that device I showed you earlier, install it, and you have television, two-way television communication. So this means that the drones are tremendously more problematic than I think most people realize they are. Let me just go back here, sort of fluctuating around here. So if we look at the amount of damage one of these drones can do, you can see This is probably one of the drones with a smaller warhead, maybe a 100-pound warhead, and this is a drone with maybe a 100 or 200-pound warhead that hit a building. And we have lots of videos of these drones hitting buildings. So the situation is really not very favorable to the West. In this case, both Israel and the American military bases in the Persian Gulf, because the satellite information given by China and Russia is very detailed. And you can have a drone en route, and it could be taking an hour or two to get, or hours to get to the target area, but you can update it, 10 minutes before it arrives in the area. So no wonder Bahrain is in flames, because the Iranians are getting real-time data on what's going on in Bahrain, and these drones can come in. They can hit radar systems, which reduces the chances of the radars detecting them for interceptors to be launched, and they can then go about their business without worrying about air defenses. So as time goes on, the attacks will be more and more effective, because what's going to happen is the radars are going to be depleted over time. And also the interceptors are going to be depleted. So these air bases are going to see more and more damage over. The only possibility that they will start seeing less damage is if the Iranians run out of drones. And there's very little reason to believe that that's going to happen, because these drones are being manufactured in real time, and there are probably hundreds per day that can be manufactured. The Russians are manufacturing thousands per day. We also don't know if the Russians or the Chinese will decide to transfer more drones to the Iranians, because this is a war that's now becoming of concern to the Russians and the Chinese, which is part of the reason they're already beginning to help Iran. So this is not a situation that is going to develop favorably for Iran. Now, in addition to these problems, we have the problem of countermeasures that we're seeing in the ballistic missiles. Unfortunately, this will not be as organized as I would have liked it to be, but let me just show you a few images, and then I will describe them. I'll show you some videos. Again, I apologize for the discombobulated presentation, but this is an Al-Fatah warhead. Now, what you see here is the warhead. This section is the explosive section. These fins allow the warhead in the atmosphere to be guided. These fins will be effective. I've done aerodynamic calculations in the past over other. I can tell you that this vehicle can start maneuvering in a significant way at 25 or 30 kilometers altitude. These fins, even though the air is quite thin at 25, 30 kilometers, these fins can provide enough lift that you can reorient this vehicle and cause it to maneuver. This rocket motor has two effects. It creates thrust to increase the speed of the incoming warhead. The incoming warhead might arrive at the top of the atmosphere at about 3 kilometers per second, so Mach 10. But it can easily get another kilometer per second speed while going into the atmosphere from the rocket motor. Now, what most people, well, very few people, if any, would know this, it's just because I've been working on looking at this thing over many years. What this rocket motor does is that when the warhead gets to lower altitude, and these altitudes may be 5 or 10 kilometers, this motor is still releasing gas. This gas comes out of the back of the vehicle and reduces the drag on the vehicle. In other words, the air is flowing over this vehicle at low altitude, at very high speed, Mach 12, Mach 13. So there's kind of a vacuum. Behind this vehicle. That vacuum creates a pressure that's pulling the, this is called base drag. It's pulling the vehicle from behind and causing it to slow up. But this rocket motor continues to emanate gas, and that gas then alleviates the vacuum so that now the vehicle is not being pulled from behind, and the vehicle comes in at a higher rate, doesn't slow down nearly as much. So these things are hitting the ground at speeds in excess of Mach 10, Mach 12. It's at a speed of Mach 10, this vehicle has twice the explosive capability, does twice the explosive damage as its total weight, because the weight of the vehicle alone gets converted by kinetic, because the velocity is so high, gets converted to thermal energy, to just explosive energy, plus the exploding munitions. So this vehicle delivers twice. So this could be delivering 2 tons, potentially 2 tons of explosive power. That's a lot of damage inflicting capability. Here is something that I'm still a little speculation on this, but I'm pretty sure we understand this at this point. I'll know more about it probably next time we talk. You can see here this bright plume behind this leading edge, which looks like some kind of cone-shaped vehicle. This is probably a high-altitude maneuvering warhead, a warhead that has a low thrust motor, rocket motor, which is maneuvering at high altitude to change its trajectory. And the reason for that is this vehicle is changing its trajectory because the way the missile defense works is it takes literally minutes for the interceptor to get to the intercept point when you're going at high altitude. When you're talking about THAAD or Arrow, these interceptors take a long time to get to high altitudes. They have very minor divert capability. So the divert capability is very small. The divert capability is designed just to allow them to be able to make minor adjustments so that they can hit the target when they do, which is rare. So if I can 500 kilometers away divert this missile, by the time this Arrow interceptor gets to a location, it's too far away to maneuver. So I can just fly by it. So that's what this is designed to do. This is a countermeasure. Frankly, I don't think it's needed because I don't think the Arrows or the THAADs are functioning at all. I think, and the reason we know this is we can only see what's going on at low altitude. But if you look at low altitude, the air is filled with incoming ballistic missiles. So you have to say to yourself, what's the upper tier doing? The upper tier is not intercepting stuff or a lot of stuff because all this stuff is coming in at the lower tier. That's what we see. We don't see what's going on in the upper tier, but it's clear that the upper tier is making almost no difference, if any. So, okay, here is just an example. I'll relate this very quickly to the situation in Iran and in Israel. This is an Iskander ballistic missile. This is a much shorter range ballistic missile. Comes in at a much slower speed. It's completely defeated Patriot missiles in Ukraine. The Patriots, they're claiming a 5 or 6% intercept rate with the Patriots. I doubt it's that high. And I doubt it's been that high throughout the war. Because this thing can maneuver, and the Patriot cannot maneuver to match it. So if we look at this missile, let's just look at the back end of it. If we look at the back end of this missile, we can see that there are fins. These are in the. This is the rocket exhaust motor. This is the actual rocket engine, and the exhaust comes out through this nozzle, and then these jet vanes deflect the nozzle, deflect the exhaust, so that you can maneuver the missile. It's an old design. You don't need to be you wouldn't use it in the longest range missiles because you lose efficiency, but you don't care. You want simplicity on this shorter range missile. And notice there are these kind of attachments here. What is in those attachments are decoys. Here's a picture of one of these decoys. It's got electronics in it. There's no reason at all why the Iranians can't be deploying simple things like this. We haven't seen evidence for it yet. But this is the kind of thing that toss it over the fence to the Iranians if they haven't done it on their own. If you're talking about Russian aid to the Iranians. What I'm trying to do here at this moment is give you a case of why things are going to go to hell in a handbasket as this war goes on with regard to attacks against U.S. bases in the Persian Gulf from the drones, as well as the ballistic missiles, but also damage to Israel itself from ballistic missiles. This is going to go downhill big, and we're only beginning to see, how bad it's going to get. Here is just a picture of this particular decoy. This is the Russian decoy. Notice again, you see back here, there's evidence of some kind of burning material. That's because when that decoy is deployed, it's deployed from the back of the Iskander, and it's got a little small amount of rocket fuel at the back to push the decoy slightly forward. So there's a cloud of these decoys around the incoming Iskander. And these decoys are radiating electronic signals. Now, they could be doing several kinds of electronic signals. They could just be jamming the radar, because if they're close enough to the Iskander, then the beam of the radar is still pretty wide. So if I'm in the beam of the radar with a decoy and it's just a jammer, there's no way for me to null the jammer out. If the jammer is far away, I can null it out. And the radars are capable of doing that. But if it's right in the main beam, I can't do it. So I could be just jamming the signal, which takes no effort, or I can be mimicking the radar signal. Every time the radar pulse hits, I record the pulse and I send it back, so I create a giant false image. This is what Israel is going to be facing in the future, if it isn't already facing. So these countermeasures have been existing for years. And I've largely been alone talking about this, but I've been warning people for decades about these countermeasures. So you not only have the United States spending hundreds of billions of dollars on a strategic ballistic missile system that can be defeated with these measures, but you have tens or hundreds of billions of dollars on shorter range missile defenses, which are also being defeated by the same countermeasures, but against more tactical systems rather than strategic systems. This is a gigantic technical fraud that has been going on for decades. And the argument has always been, well, we don't see countermeasures. And my statement is, well, of course you don't see countermeasures because there's no need for them. As soon as there's a need for them, you're going to see them. And of course, now we're seeing them. So the prediction from 30 years ago is coming out in spades now. So here's give you a sense of the size of one of these decoys. They're not big. And if we want to see, this is an Iranian submunition. It's looking all over the place. This is a submunition. It probably contains about three or so kilograms of high explosives. This particular one didn't detonate. It landed on the ground. You can see that it had wings that fold out. So the wings fold in to these cavities here. The submunition is thrown out, and the wings deploy. The submunition immediately stabilizes. So when you see these things, if it doesn't stabilize, if it tumbles, it's going to slow up and it's going to hit the ground at a subsonic speed. So you're going to see this munition like we see it here. But if the fin deploys quickly enough and it doesn't tumble and it stabilizes it, this munition will go right along with the main vehicle. And we can see this in videos. I don't know if we have any time to look at it. We probably don't have time to look at a video now. I don't know if you're willing to. Here's another example of a strategic decoy. This is in Russian. I brought this, I actually originally brought this in 1996. In 1996, I was in Russia and somebody gave me the first photographs that I'm aware of this decoy. And I took it back to the United States. I was talking to the Russians. I told them I was going to give them to the Americans. And I wanted, I said, it's in the interest of both countries that there not be missile defenses to complicate the arms control situation. The Russians did not want the Americans to be building missile defenses because they knew they would have to compensate for them because they couldn't ignore it. You just can't ignore this kind of thing. It's too much on the line. So they showed me one of their decoys, and I said, well, if you give me the image, I'll take it back. I'll give it to the Pentagon, and I'll explain to them what it is. And they gave it to me. So so the Pentagon was certainly informed that the Russians build these kinds of decoys. This is an electronic replica decoy is what I'd call it. And it would fly along with strategic warheads. Now, when I was in the Pentagon, just to show you how the intelligence system failed, we would observe flights from Plesetsk in Russia. The Russians would launch ICBMs from Plesetsk in Russia to Kamchatka. They'd launch these missiles over Russia. So these would be strategic ballistic missile tests. And the Russians would deploy their warheads. You'd have an incoming, what's called a post-boost vehicle. And this vehicle would have a rocket motor that's causing it to slow up. And it would go along what's called the range insensitive axis. I can describe this at a later time if people are sufficiently interested. This is a direction in space where the warhead will land on the same location, but it will follow a slightly different trajectory. In other words, if it's slower, it'll follow a trajectory like this. If it's faster, it'll follow a trajectory like this. But everything will land on the same trajectory, on the same location. So the Russians like to deploy their warheads along what's called the range insensitive axis. Well, we would see the Russians deploying their warheads. We could observe them because we had imaging radars, synthetic aperture radars. The Russians understood we could do this, but so be it. But what we'd also see is a large number of reentry vehicle associated objects. I even remember I used to see this in the intelligence, RVAOs. So I would say, for Christ's sake, these are decoys. And they'd say, no, they're not decoys, they're RVAOs. I say, what? I talk to these intelligence people. I say, do you understand that what the Russians are doing is they're testing their deployment, the stability of the decoys as they're deployed, and they're not showing you the actual decoys. They're showing you canisters which are designed to match the moments, what they call the moments of inertia of the actual decoys, which they're not showing you at this point, but they're testing the deployment scheme to make sure that when they deploy these decoys, they don't tumble or do something unexpected. This is evidence of a serious countermeasure effort on the part of the Russians. Oh no, they're RVAOs. So here you have the intelligence community not, you can say, look, you can say what I just told you. In other words, you're the decision maker, Glenn, and you say, what is this? And I say, look, we can't say for sure, but let me explain it to you, Glenn. Glenn, sir, you're the decision maker. These are almost certainly, in fact, they have to be, replica decoys. We're not seeing the actual decoys. They're testing to make sure that when they deploy the real decoys, they'll behave exactly as we see them here. There is no other thing they could be. But the intelligence community wouldn't tell you that. So now let me just show you how ubiquitous this problem is. This is 4 images from the test of a ICBM, solid rocket ICBM that was tested by North Korea. This is North Korea. What you see here is an upper rocket stage burning out. This violet, purple looking area is just the rocket motor burning out. Here you see something being ejected. Well, let me show you what that object is. That is a canister of chaff. So this is a North Korean missile. So here you see, this is a U.S. Navy chaff dispenser. So you have chaff that's one length. Here's another length. Here's another length, because they're different lengths depending on the radar frequency, because you want to be a big puff cloud. Now, each one of these things can be effectively a decoy at high altitude in space, because the chaff just moves along with the warhead. So I can create a chaff cloud, and the warhead can be inside it. And I can create another chaff cloud, and there's no warhead inside it because the radar can't see inside it. So I can, in essence, create all these chaff, which is what I would do if I were the Iranians, because I think it's too much trouble to do what they're doing. But they know what they're doing, and they obviously are extremely well informed about the countermeasures, and they are absolutely able to implement these countermeasures. And we're seeing them from Russia, North Korea, Iran, China, we know has a big countermeasure program. So all these missile defenses, whether they're strategic or tactical, are worthless. And all of this money that has been spent and all of this false claims that we can protect the public, the population, from these ballistic missiles, all this false claims are now being shown to be false over 35 years. I've been talking about this for 35 years. I can give you, if I didn't have such a short time, I can organize a talk. I can show you slides from 35 years ago that I showed to the International Institute for Strategic Studies. and had people say, well, what can we do about it? I was in London 35 years ago. These people come to me and say, well, what can we do about it, Dr. Postol? And I said, I'm telling you because I'm trying to alert you to the fact that you can be defeated and there are no countermeasures to these. I'm trying to warn you that you cannot deal with these things when the adversary chooses to react. Oh, you're a negative person. Well, I'm just a scholar trying to inform you of what's technically doable on both sides. And, you can't, the sensors, this has nothing to do with interceptors. They want to show you rockets launching from the ground and interceptors. This has nothing to do with interceptors. This has to do with sensor systems. If the sensor can't see what's a warhead and what isn't, you cannot make interceptions. You don't know where to send the interceptors. And that's the situation we're in. And things are going to go to hell in a handbasket in Israel. And they're going to go very badly in the Persian Gulf military bases as the radars get depleted by drone attacks. The radars are going to get hit. Sometime they'll be able to intercept, sometimes not. As the radars get depleted or the interceptors disappear, because there are none, you're going to be left with nothing but guns. In fact, there was some video I saw just a few hours ago of gunfire from one of the American military bases labeled that they were using guns to try to shoot down the drones because they had run out of interceptors at this particular base. That's what we're looking at. So I have a bad story to tell you. It's nothing as spectacular as what Larry had to tell you from a broader view, but from the little keyhole of a technologist, things do not look good in the next part of the war.
From watching this interceptions though, or attempted interceptions, so what is your general idea though about ability to defend? I mean, you covered his quite well, but is it diminishing fast? Is it was it never great?
It's diminishing fast, and it's diminishing fast. It's diminishing from a very low number fast. I mean, the interception. This is a total fraud perpetrated not only on the public but also on. I mean, you can find, Mike's. As you may know, in the Gulf War of 1991, I was the sole voice, along with my very talented colleague George Lewis, describing the Patriots' failure in the Gulf War of 1991. We eventually showed, and it was eventually accepted, that the Patriot had not intercepted a single Scud warhead in the Gulf War of 1991. Now, the Patriot used at that time was the Patriot PAC-2 interceptor, which was a bargain at $1 million each. Now you have the Patriot PAC-3, which has some improvements, and it's a bargain at $4 million each. But the problem with this interceptor, although they have made improvements that were clearly aimed at solving the problems with the PAC-2, which failed catastrophically, it turns out the PAC-3 is also failing catastrophically too. It's maybe got a 3 or 4 or 5% intercept rate against long-range Iskander and longer-range ballistic missiles. So we have not been seeing a high level of intercept rate even earlier. And what you see, this is deja vu all over again, as I joke with my friends. In the Gulf War of 1991, we got all these videos, and we were analyzing the videos, and the videos were very hard to obtain then. We didn't have all this stuff on the internet. So we went to broadcasters and we begged them to allow us to copy their broadcast videos of engagements. Took us months to collect the videos. And in each of these videos, you would see the misses. In fact, we collected the videos and we showed that they were all misses. So we had, a large number of videos. And if you listened to the people, the journalists talking, they would say, "There's a hit, there's a hit, there's a," and what they were calling hits were the explosions of the Patriot interceptors, because they have a warhead on them, in empty space. I could show that video if you're interested. I could do that on another show.
Yeah.
It's kind of an interesting piece of history, because this is what happened in the Gulf War of 1991. And since there's no memory in either journalism community or even in the military community, I'm afraid, we're seeing the same thing. We're seeing Patriot PAC-3s exploding in the air. They make little fireballs. They're not intercepts. They're just detonations in free air. I can show you, again, if we have another, I can be more organized. I can actually, if you think we want to schedule something, I can go through what an intercept looks like, because we have evidence of intercepts. Very, very, very unusual, but we've been able over time to find them. That's because we have dozens and dozens and dozens of videos where there are no intercepts, and every once in a while we find a video where there is an intercept. It's not because intercepts are common. It's because they're so uncommon we have to go through video after video after video to find them. But we know we can see intercepts. That's what's important about finding one. Because the fireball from an intercept is very big and very distinctly larger and brighter than the fireball from an exploding Patriot PAC-3 interceptor. So that's how you can tell it's an intercept. And that's because the Patriot PAC-3 runs into the front of the warhead and detonates it. If it runs in the side and detonates, no cigar. So that's what's going on. The intercept rates are very, very low. They have not gotten, if they're lower now, it's only because they run out of Patriot interceptors to use. And it looks like there may have been some successful Iron Dome intercepts, but even they're at a lower rate yet. So I would say between Iron Dome and the Patriot PAC-3, the intercept rates have been a few percent at most, when the interceptors have been available.
Well,
and things are going to get worse because they'll run out of interceptors, but I don't know if it matters much. What is going to get worse is the damage inflicting capability, because these accelerated warheads, these ones that have powered flight below altitudes, do a lot more damage when they hit the ground because their kinetic energy is very high. They almost double the explosive power because of all this kinetic energy being converted into explosive power. And we're seeing more and more of these come in. And I can show you some of them in a follow-on discussion. And they do tremendous damage. They are really doing damage on the ground. I just exchanged just my wife came in and showed me just before a message we got from very good friends we have in Israel, who have been against this Netanyahu. We don't have I don't have a good firsthand sense of what's going on in Israel in the population, because all our friends are against what's been happening there. But we were told that things are hellish on the ground. That's what we were told. Things are hellish on the ground. And they look hellish from what I can tell from videos. And it's going to get worse. This is going to go on. It's going to go on indefinitely. We're only 7 days into the war, 8 days into the war.
Well, once the war can't be won on the ground anymore, we often see that the strategy, the tactics, and the targeting also changes. Only over the past day now, we've seen
my concern.
What?
My concern is that this homicidal maniac will resort to using nuclear a nuclear weapon against Iran. And if that happens, Iran will respond. Whether or not they now have nuclear weapons, it may take them a few weeks, but they'll have the nuclear weapon and they will respond. That's what we can have. So I hope the United States has control over the Israelis that they'd like to say they do, because I don't know if anyone can stop this guy. We have been playing with fire with this guy, Netanyahu. This man is a homicidal maniac. So I am extremely worried. I'm getting more. And incidentally, if Larry disagrees with me, I'd be interested to know. I mean, we should bring it up. I saw Larry's comments just on your show earlier. I think he agrees with me, but I'm not sure. But I really value, because of all of his insider experience, which I don't have. But I'm becoming very concerned about what's going to go on over the next months or even year or more.
Well, it should
This
be.
is not going to be free.
What I was going to say is from the attacks on the fuel depots now in Tehran, we have this toxic rain which burns skin, destroy lungs. We have attacks on the desalination plant, which provides water, which is also a war crime. And Trump, recently now made a statement that the map of Iran will probably not look the same after this war. So it looks as if, I'm not sure if it's going to, from introducing Kurdish fighters. Either way, I think the escalation is really going out of control. So the prospect of a nuclear weapon, should not be ruled out as they failed to win.
Well, Glenn, you're obviously a deeply studied person on this subject, more so than I. But I have to tell you that I'm beginning to become concerned that we're walking into a global nuclear war. I think it could escalate. It would stay in the Middle East initially, but God knows where it could escalate. There's so many unknown parameters at this point. But hopefully it won't happen. But if it starts in the Middle East, it doesn't have to spread. But there are lots of scenarios where it could. So we are really moving into unknown territory.